6th International Conference on Advances in Material Science organized by the Raje Ramrao Mahavidyalaya, Jath, Sangli. I, Dr. Ramesh Vishe, OP number 67, presenting a research paper entitled by Yttrium Composition Influence, Microstrain Porosity Hooping Length Properties of Nickel Cadmium Yttrium Doped Nanoferrites Materials. Nanosciences combines knowledge from the various sciences of physics, chemistry, biology, medicine, and engineering. The applications and use of nanomaterials are extensive, such as electronic, mechanical device, optical magnetic component, tissue engineering, magnetic storage system, and magnetic resonance imaging. Material technology is a new technology for synthesis and processing, manipulation, and assembly using nature's own building blocks like atom, molecules, and macromolecules for the intelligent design of functional materials, components, system with attractive qualities and functions. Ferrites are well-known magnetic nanomaterial intensively studied as a recording media due to their superior physical properties. These properties make ferrites as an ideal candidate for the technical applications such as magnetic resonance, imaging enhancement, catalysis, sensor, and pigments. Mixed spinel ferrites have been studied intensively over the last few years due to their potential applications. In this work, nickel cadmium yttrium doped nanoferrites were synthesized using solgel atom combination method. X-ray diffraction were used in order to investigate the structural properties of these samples and to determine the lattice parameters. Materials and method. The yttrium doped in nickel cadmium ferrites powder were synthesized by the solgel atom combination method at low temperature for different composition of nickel ferrites, nickel nitrate, cadmium nitrate, ferric nitrate, and yttrium nitrate. AR grade nitrate of the Merck company with purity of 99% are used in this experiment. Citric acid is used as a fuel. The proportion of each reagent was defined according to its respective molecular amounts. All chemicals were dissolved in double distilled water and it will be stirred to obtain homogeneous equation. Ammonium hydroxide is added drop by drop into the solution to maintain pH equal to 7. This solution was stirred continuously with 80 degrees Celsius for about 4 to 5 hours to obtain the sol. After 4 to 5 hours, gel is converted into ash and ash is converted into the powder. Finally, we get the final powder of these samples for using a atom combination technique, and powder was sintered at 400 degrees Celsius for 2 hours. Result and discussion. We take as a XRD analysis. Crystalline phases were identified and it is confirmed for the formation of homogeneous well-defined spinel cubic structure without any impurity. The broad peak in the XRD pattern indicates fine particles nature of the particle. This particle size will be determined using Shear's formula T is equal to 0.9 lambda upon beta cos theta, where lambda is wavelength of the X-ray, theta is a peak position, and beta is a full wavelength half material of the theta. In this diagram, we see that big peak will be shows there is a formation of the homogeneous equation and getting a synthesis of the material. And in this table, we find the particle size in nanometers. Whenever concentration of the yttrium was added into the solution, particle size of the material samples go on decreasing, and we find respectively lattice constants also go on increasing. Then we see in this structure, whenever you are increasing the yttrium concentrate into the material, graphically we find that its particle size go on increasing, and it's similarly the variation we have observed into the graph. The particle size decreases at the concentration of atrium increases. The lattice parameter obtained for the preparation of sample is ranging from 0.3399 to 8.3665 angstrom, and the particle size, which you call it as a grain size, ranging from 12.5 to 34.8 nanometer. The deviation in the lattice parameter is observed due to the cation rearrangement into the nano size prepared by the ferrites. The values of the lattice constant for this nickel natrium dope into the atrium ferrites shows expansion of unit cell with the rare earth doping when compared with the pure atrium ferrites. This is expected due to the substitution of the large ionic radius of atrium ions with the small ionic radius of the iron material. This result in atrium substituted ferrites to have higher thermal stability relative to the nickel cadmium ferrites. Then microstain, we find the one property of the material using this XRD. Microstain is a root mean square of the variation into the lattice parameter across the sample, and that is determined using a Wilson formula. Epsilon is equal to beta cos theta upon 4, where epsilon is the root mean square value of the microstain, beta is the peak width of the half maximum density, and theta is the peak position. And for that we find that the microstain is compared sample increases if concentration of atrium doping increases into the nanoferrites. It increases from 0.7928 to 0.1211. This change in microstain refers to change in lattice parameter caused by the due to the doping of atrium into the nanoferrites. Then porosity. Porosity is measure the void spaces into the materials. The percentage of porosity is determined using the formula that P is equal to 1 minus small dB upon dx, where dB is a bulk density and dx is a X-ray density. So we should determine that densities using this formula which we have indicated here, and similarly we find out the specific space area which is calculated by using the S formula. S is equal to 6000 upon epsilon dB. Okay, so in table we have calculating all these values using the formula and put into the table, and the variation will be shown by the graphical. Okay, so porosity is prepared sample increases if concentration of atrium doping increase into the nanoferrites. It increases from 58 to 70. More porosity refers to fraction of the total volume in which gases are presented. Therefore, understanding of the morphology is very important. The X-ray density decreases and surface area increases if concentration of atrium doped into material is increases. Also, X-ray density is also greater than bulk density. This is due to the some unavoidable pores creation due to the sample preparation and scintillating processes. Then hooping length. Hooping length is a ion jumping length, or it is a distance between the magnetic ions for the both sides A and B. Okay, so distance between magnetic ions is a hooping length, and it is calculated by using the formula. For octal side, it is determined using a under root 2 upon 4 into A. Okay, and then tetrahedral side, it is determined using the formula under root 3 upon 4A. Okay, now we are calculating all these hooping length and putting into the tables, and similarly we see the graphical presentation that it is continuously go on increasing while increasing the atrium dope into the samples. Then secondly we have analyzed EDAX. So EDAX shows atrium is less than that of normal composition due to the segregation of the atrium ions into the grain boundaries and evaporation at the high temperature. This particle size, or which is called as a grain size of the sample, decreases with the increasing of the doping of the atrium ions into the samples, because more cations vacancies close pores exist and grain boundary movements when a large amount of yttrium ions exist into the sample. Then finally we conclude this research papers. The rare earth yttrium dope nickel cadmium nanofarads, yttrium dope in a nanofarads were synthesized by using a solgel atom combination technique. The increase in yttrium concentration gives the significant change into the particle size of the composition. The prepared samples were characterized by the XRD and EDX and give the confirmation of nano size. These XRD of the sintered nanofarad shows crystalline size decreases as concentration of doping material increase, and then size of the particle observed was the range of 17 to 23 nanometers at 400 degrees Celsius sintered, and provide information about the spinel cubic structure. EDX shows the content of the yttrium was less than that of normal composition due to the segregation of yttrium ions into the grain boundaries and evaporation at the high temperature. And the determined values of the microstrain increases while porosity, hooping length, XRD and lattice parameter decrease with the increasing of the yttrium concentration. Thank you all of you.